Good morning, everyone. Thank you for taking a little time and learn a little bit about our products. I think you can all see that first slide now, LMR Cable Benefits. The LMR cable is a very low loss cable, and it addresses a lot of the weaknesses in other cables that are out there in the market. It's very flexible. It's not going to kink. It doesn't have an air dielectric. It doesn't have the fragility of some of those helically corrugated copper cables. There's cables out there that use air dielectrics like Bella 9913 that are very susceptible to kinking. Corrugated cables, of course, very susceptible to kinking. It's extremely easy cable to terminate, as we'll demonstrate a little bit later on. Very easy to install, and the loss is comparable to the annually corrugated cables, but with not the stiffness that you'd have to deal with an annually corrugated copper cable. Much lower loss than the RG cables. The RG cables pretty much are solid dielectric, solid PTFE, solid PE. They tend to be round wire braids, single round wire braid, double round wire braid. So you're talking 40 dB shielding effectiveness, 60 dB shielding effectiveness versus the 90 dB of shielding effectiveness of the LMR product. So with the LMR product, you have a low loss dielectric, and you also have very good shielding effectiveness, which both contribute to giving you a nice low loss cable. And there's pretty much a cable size for every loss budget, as you will see. So how is the LMR cable constructed? For this very small cables up to LMR 300, it's a solid copper center conductor. It's copper clad aluminum, 400, 500, 600, and then a hollow copper tube for the larger cables. These RF energy travels on the skin of the center conductor, so hollow tube would work just fine. Takes a lot of weight out of the cable. The dielectric is kind of the secret sauce. It's a combination of high density and low density polyethylene. It's nitrogen injected. It's closed cell. Water cannot penetrate through that dielectric. What we're looking to do with the dielectric is to approach air in terms of density. So velocity, we're looking, certainly to approach, 100% velocity. What we have here is a range of velocity from about 82 to 86% with this dielectric, which is very high performance dielectric. We don't want to increase the velocity any greater than that, because at some point that dielectric will become soft. It'll become very susceptible to clamping or crushing or that type of thing. So it's a combination between, improving that dielectric for loss and keeping it rugged, to keep it so it can be used and handled out in the field. The shielding, it's a composite tape, aluminum mylar, aluminum composite tape. It's cigarette wraps around the dielectric and is bonded to the dielectric, and it's got an impression in it, so it's designed to flex. It's 90% 90 dB of shielding and designed to flex. And then the jacket is a carbon-filled black polyethylene, extremely good UV resistance. Next slide there. These are some of the common constructions. You have the standard LMR product, and we have many different versions of the LMR. Right below that, you see the LMR DB. That's a flooded braid right below the jacket. It's a silicone-like material that we flood the braid with, and it pretty much becomes impervious to the environment at that point. If the jacket was ever breached for any reason, could be a rodent wanted to get a taste of the cable type of thing, or the cable was rubbing up against something sharp over time and there was a breach in the jacket, that water's not really going anywhere. It's running into that DB blocking agent. Even the standard cable, we pressure the plastic into the braid. So we're trying to remove any air that's in the braid, and we do a pretty good job with that. If you take the LMR cable and you peel the jacket off of it and turn it upside down, you'll see that heavy braid impressions in the jacket. So we're looking to, mitigate the possibility of any water, moving through the cable. And we also glue the foam dielectric to the center conductor. So in the electrical path, we don't want any water moving around. But with that DB, that gives you the extra safety factor in case that there is ever a breach there, you're sealed. Right below that, the FR cable, that's a fire retardant cable. It also happens to be a non-halogen cable and a low smoke cable. The FR, the DB, the LMR, they all work with the same connectors. Just different jackets and that flooding agent in terms of the DB. Over on the right, you'll see LMR LLPX. That's a plenum rated cable. It's extremely low smoke in addition to being a fire retardant cable. The platinum cables are primarily, the demand there is primarily in the US and Canada for platinum rated cables, but the LMR LLPX also happens to be a high temperature cable. So if you have something where you're out in an unair conditioned facility, a radio room, somewhere out in a real hot environment, maybe something you want to look at, you've got to run cables for, say, an engine compartment or something that's very hot. The standard cable is good to 85 degrees centigrade. The LLPX is rated to 150 degrees centigrade. So it's also a high temperature. Right below that, you see the UF. That's a flexible cable. Now, you can't bend that any tighter than the standard cable in terms of its minimum bend radius, but its bend moment is much better than the LMR. So it's designed for in the cabinet, getting up and over and around things, just making it easier to route the cable. The cable has a 7-strand center conductor and a rubber jacket versus the solid center conductor and polyethylene jacket of the standard product. There are, a couple of things to consider with the LMR. It's greater insertion loss because of that stranded center conductor. So you pay a little bit of a price in terms of insertion loss. It's a little more difficult to field terminate, to prep with that rubber jacket versus the polyethylene, and you're limited to solder pin connectors. We'll talk a little bit later about the EZ style connectors, but you'll have to solder onto that stranded center conductor. So a little more work to terminate it. And then right down in the lower right-hand corner, we got our LMR light, and all we do is replace the tinned copper round wire braid with aluminum. So we bring the weight down and we bring the cost of the cable down. So if you have a very large project, it might be something you want to consider. Electrically, it's basically the same as the standard product. And we talked about, having a cable size for every possible loss budget. You can see here from LMR 100 all the way up to LMR 1200. So, there's always a cable there. If you need just a little more loss performance, you can just go up to the next larger cable size and you have that right there. Yeah, next slide. Connectors. So in terms of, the overall loss of the RF interconnect, the cable certainly plays a big part in that. And we mentioned, the foam and how important that foam is and the shielding effectiveness of the LMR cable. But the connectors also play a big part, especially in shorter assemblies. A lot of what you hear sometimes, you hear connector loss. A lot of times what that actually is mismatch loss, which is caused by impedance disuniformity, and it's measured in VSWR or return loss. And that's where a lot of the loss comes from. But with our connectors, they're compensated for, very good impedance uniformity through 8 gigahertz. So that's very important. At times oftentimes hear people add a 1/10 of a dB or 20th of a dB per connector, and that just seems very, very high. If a connector is designed properly, it's not going to really contribute all that much to the loss of the interconnect. In terms of its electrical length, the connector, doesn't represent a whole bunch of electrical length. So, good compensated, good impedance uniformity, you're not going to see a whole bunch of loss. Now, our connectors, there's a lot of things that we look to optimize there. From an environmental standpoint, our connectors are either tri-metal plated or bi-metal plated. Both of these platings offer some excellent corrosion resistance. We're very concerned about coupling knot retention. That's important to us. Cable to connector retention is important to us. Those are things we look to optimize. The connectors are rated to IP67. So the right angle joint has a brazed right angle joint. The solder right angles have O-rings and counterbores in them. You'll notice all our connectors have ribs in the back that interface with either adhesive line shrink boots or WSB silicone boots that snap into the back and create an IP67 seal. The pins are plated 50 microinches of gold. So it's just, very rugged connectors. Next slide. The thing is, there's lots of different interfaces out there. Just a few of them, Ns, TNCs, BNCs, 7/16 DINs, SMAs, QMAs, and you can go on and on. Males, females, bulkheads, right angles. So, and then you look at all the different cable possibilities that are out there, different cable sizes. So to keep up with, real, the best quality connectors for all these different cables, it could be a little bit of a challenge. So what we did is we developed these modular parts. We developed connector heads that we can use on pretty much any cable. We can mix and match with different cable entries, different connector heads and right angle joints. This is a way that we can address less common connector configurations. while at the same point providing all the characteristics that we just mentioned in terms of corrosion resistance, really low VSWR, compatibility with WSB boots, compatibility with the tools and CST tools. And the next slide. Just gives you a little idea for the modular, how it works, just building blocks. You can use a straight, use a right angle joint. You've got a whole bunch of different cable entries. And this is something that allows us to address, less standard configurations and do it quickly and do it cost effectively. And by using the modular system, it allows us to do things that we couldn't, do cost effectively without the modular system. We mentioned black coupling nuts. That's something we're doing right now. Flat black coupling nuts, lock wire holes. We can do that. Stainless steel connector heads. We've done a little bit of that. And there's really kind of the sky's the limit. We've done some RG cable connector entries, so we can provide good corrosion resistant, low VSWR connectors with have all the characteristics, the ribs in the back, compatibility with CST tools, that type of thing, for just lots of different cables at this point. The CST tools. So we mentioned, in terms of a low loss interconnect, the cable plays a big role. The quality of the connector plays a big role. If you can't, the termination between the connector and the cable, that transition is very important. And if you can't do that easily and consistently and don't have the tools for that, that's a real challenge. So we've developed these CST tools that provide a nice, clean, sharp cut, expose the center conductor without crushing the outer conductor at all. We can deburr the center conductor and then just peel off that braid so that we're exposing the right amount of braid every time. We're not nicking the braid wires, so we're maintaining that, mechanical strength, tensile strength that we need. And we have a different CST tool for all the different LMR cable sizes. These are just the 6 standard, and then we have a lot of specialty CST tools as well. And you can kind of see in the photos right below there, just to get a little feel for, just take that pellet right off and peel the jacket back from the cable. The cutting tool, it seems like, that's maybe a minor thing, but, it's the first thing you do to get started. And a lot of different, cutting methods out there that people are using, they're crushing the cable, coaxial cable, and you're really kind of, you're behind the 8 ball before you even get started. This tool here is a spring-loaded tool, very easy to use, very ergonomic. We tested it to 2,000 cuts. You can see some of the little pieces there, and still cuts, very cleanly without crushing the cable at all. Really great for some of the smaller core LMR cables. What you're doing is you're cutting the center conductor without bending the center conductor. A lot of these coaxial cutting pliers or diagonal pliers are going to bend the center conductor, burr the center conductor. And what you're doing with this tool, you're not chopping through the center conductor. It's like cutting a piece of glass. You're scribing the circumference of the center conductor and just snapping it. So you're not getting really much of any burr, which is very helpful in terms of the rest of the termination process. What we're looking at here is a hard case toolkit that we released late last year. This is for LMR 195 and LMR 240, and everything's right there in place. If you're going out and working in the field, you pop the lid and you see you got everything you need. You got the cutting tool, the crimp tool, and the 2 different CST tools. This is another kit here that we're just releasing currently. This is for the LMR 400. Same cutting tool, different crimp tool there, but same size crimp tool, and CST tools for the standard LMR 400 and the 75 ohm version of the LMR 400 as well. This is something that's a fairly new radiating cable CST tool. We have a TRAD 600, uses the same connectors as our LMR 600. TRAD 600 is a radiating cable. And what we do here, this cable does not have a braid wire on it. So what we do is we crimp onto the outer jacket. What this tool does here is it takes a pellet off of the center conductor, exposes the center conductor, just as the other CST tools do. It has a deburr bit on it and deburrs the center conductor. And then it makes two slices, 180 degrees apart in the jacket. And you just peel the jacket back like a banana type of peel. So this does it, consistently, very easily. You're not going to use a razor or knife. Next slide. WSB boots. A little earlier we mentioned WSB boots. We have these pre-molded boots for all the different cable sizes now. And as we mentioned earlier, with these ribs, all the connectors have ribs in the back, and these boots will snap onto the ribs. We provide a little rubber lubricant that you just put a drop. It's quick drying. It's biodegradable. You slide the boot onto the cable prior to terminate it, and just snap that in place. This takes the place of the adhesive heat shrink boots. Adhesive line heat shrink boots are supplied with the connectors. If you work out in the field, sometimes dragging heat guns and extension cords and things like that out into the field is it's a challenge to work with that and get have availability to the electrical power. This is something that's very, very consistent. The thing with the boots too is you have to heat it enough to activate the glue and make sure the glue makes a copolymer bond with the jacket and make sure it really bonds properly to the connector, which takes time, there's technique, and it's really kind of difficult to really go back and do a quality check on that, aside from actually running an IP67 test on that. So with the boots, you can just quickly look at them and they're on there, they're snapped on the back, they're on there good, and they're going to provide the sealing in the back of the connector that you require. We have these WPB boots. What these boots are designed to do is to seal the whole connector once it's mated. So you can put this boot on prior to putting the WSB boot on, and once you mate that male connector to, say, your antenna or your component, you could slide this whole entire boot up and it'll snap on to the barrel on the female connector or the flange connector or the bulkhead connector, and protect that whole mated interface from chemicals, salt fog, acid rain, that type of thing. And for whatever reason, if you do need to get back at that, you can pull that boot back and unmate that connector. We have a lot of these for our low PIM series of jumper cables for small cell. This was the first one that we introduced for LMR. We're just about ready to introduce a second one for the LMR 600 product. So it'd be a WPB-600-NM, and we'll continue to release these type of boots. We're also using them with some of our bundled cable products. Next slide. And just an overall, in terms of the LMR products, we mentioned the WSBs, the WPBs. We also have cold shrink boots. We have a silicone tape that doesn't use an adhesive, has 300% elongation for weather sealing. It's a great weather sealing product. We also have pull hoists and hangers, ground kits. In addition to the ground kits, we have tooling to provide to peel the jacket off properly to apply the ground kits. So it's kind of a complete package. The cable, the connectors, the tools, the accessories, all go hand in hand to create the optimal RF interconnect. And mentioned cable assemblies. We also build cable assemblies. We have a quick turnaround for cable assemblies for very, vanilla type cable assemblies. They could be serialized. We have smart numbers nomenclature that we place on the cable. Next slide. And just a kind of roundup of the LMR product. We're seeing as 5G is being built out, we're seeing a lot of IoT applications. The LMR product is a perfect fit for these type of applications. It's a broadband performance in terms of frequency. The LMR is rated to 8 gigahertz. All our connectors are optimized to 8 gigahertz. It's just very rugged, non-kinking. You flex it, you can almost tie it in knots. We have all the variety of different constructions, as we mentioned. The standard DB, FR, Planum, high temperature. We have even additional, polyurethane versions for abrasion resistance, chemical resistance, PVC jacketed versions, and then combinations, FR, Ultraflex, FR DB, DB Ultraflex. So it goes on and on in terms of, special constructions for special applications. The connectors are extremely easy to put on. They're rugged, they're corrosion resistant, they're low VSWR, they're compatible with the tooling, they're compatible with the boots, the CST tools, WSB boots. Everything's available in distribution, which is very critical, and complete technical support. So we're moving on to a slightly different product right here. We talked about the LMR product. We're going to talk about a product called TCOM. And what a lot of the applications for this TCOM product are these cell set on wheels, cell set on light truck, satellite dish feeds out in the field. We're seeing more and more of this type of stuff where we need this coverage in places where maybe it's a sporting event, or it could be a natural disaster or a hurricane or fire, that type of thing. And these trucks come into place very quickly and be deployed. And what's happened here is the cable's being handled all the time. Unlike most telecom cables or coaxial cables that are installed and put in place and never touched again, these cables are being coiled and uncoiled, being folded into boxes, being handled continuously. And you need a little bit of different product for that. So the TCOM really fits the bill there for this type of application. So we're looking at the cutaway of a TCOM right here. And we start off with a core very similar to the LMR product. In this case, would be very similar to, say, like an LMR 600 UltraFlex. Although the UltraFlex LMR product wouldn't have silver plating on the stranded center conductor, but that foam there is a closed cell polyethylene foam, same type of foam that we would use in an LMR product. What we did there is replace that aluminum mylar, aluminum composite tape, cigarette tape with a silver plated copper flat braid. So this cable just wants to flex. That's a concern with the LMR. You start flexing the LMR, you're going to start micro cracking that outer conductor. That outer conductor on the LMR is bonded to the dielectric, and it's almost like a tube, like an aluminum tube. And really, it's very flexible, and you could bend it to a tight bend radius, and you can form it to a tight bend radius. But you don't want to be bending it back and forth and coiling it, uncoiling it constantly. I mean, but with this flat braid, it's, as you can see, it's meant to flex. Then we have an aluminum aluminum helical wrap that we wrap over that just to kind of manage that flat braid. Then we tin copper braids similar to what you see in LMR. And we do have a TCOM with polyethylene jackets, but most of the stuff we're doing is polyurethane. Very rugged jacket, good abrasion resistance, chemical resistance, and it really fits well with a lot of these mobile communication trucks, vehicles type of application. Yeah, next slide there. Three common types of TCOM product that we sell. The TCOM is a solid center conductor, a polyethylene jacket. So very similar to the LMR, but all we're really doing is swapping out the outer conductor. But with the TCOM PURDB, we're swapping the jacket to the polyurethane jacket, as just mentioned, abrasion resistant, corrosion resistant, and adding the DB flooding agent. And then the TCOM FSDB, we use a stranded center conductor, just like the UltraFlex of LMR. And this is one type of flex test that we do. This is a very severe type called a tick-tock test. And we got, we can set whatever bend radius we want with the different mandrels there. And we just bend the cable back and forth over these mandrels. And this is something that's, it's a tough test for an outer conductor. And the LMR, it wouldn't take all that long before the LMR started breaking down with this type of test. You'd see it in the insertion loss. Start breaking down on the outer conductor, where this TCOM product just holds up very, very well. And what you're looking at there, that photo, that's a 1/2-inch cable. This is TCOM 600. This is a 1/2-inch cable. You can get to see how really you can close down that cable with that quarter there. It's very flexible, very low minimum bend radius. This is something to be comparable to like a 1/2-inch corrugated cable, where it just would be very, very stiff. This also happens to be a low PIM cable. In addition to being a cable that's designed for high flex, it's also a low PIM. There's nothing out there that really measures up to this in terms of what it can do. It's low loss, low PIM, extremely flexible, excellent shielding effectiveness, minus 100 dB of shielding effectiveness. So in a lot of applications, it really checks off all the boxes in terms of the, cows, colts, satellite feeds. We also have special connectors for it that are, low pin connectors, and also just very rugged in terms of pull strength, tensile strength type of thing, or torsional force. So just a rugged product. Here's another TCOM product, a little smaller, 3/8 TCOM 400 flexure NDB with stranded center connector. And we ran it through like a drag chain type of a test. This is not as tough a test as what we just looked at with the TikTok test, but it's something that we see quite often in a lot of equipment and a lot of different things. This was a test we ran for an MRI system for a body coil, where the gurney had to go in and out of the body coil, constantly all day long, every day, and they're concerned about the cable holding up. And you can see, you look at that VSWR plots below, initial versus 10,000 flexures, and rock solid. It's just think it hasn't changed at all, and that's pretty amazing to go through 10,000 cycles like that with a coaxial cable and just not see any change at all on VSWR. Gives you, a feel for the performance of the TCOM product. The bundle cables, we take some of the LMR cables and bundle them together. We do it in a very controlled manner. We put a certain lay length there, so the cables actually are quite flexible. The inner cables are labeled every 2 feet, cable 1, cable 2, cable 3 type of thing, ripcord in there. We do different things with jackets, depending upon the application, thinner jackets, thicker jackets. We often put fillers in there to try to approach a round cable as best we can, because it really lends itself to, sealing, weather sealing, clamps, hangers, that type of thing. More recently, we're seeing a lot of demand for smaller bundle cables, things like LMR 100, LMR 185, LMR 240, those type of sizes. We developed a bunch of multi-port connectors that go with the bundle cables as well. On this slide here, you can see some of the specialty cables we're working on. So we're doing stuff with the medical industry, where we're putting control cables and cooling tubes into the cables. We've done some stuff with bundled corrugated cables. And I think that we're going to continue to see this. There's one thing, there's smart antennas that are out there that need, have many elements. There's a demand for aesthetics, especially in urban environments. So, a small number of bundle cables versus a whole bunch of spaghetti of little cables, it's very helpful. In terms of, making sure you're hooking the right cable to the right port. The cables are I said, they're, all individually labeled, but you put multi-port connectors on there that are keyed. It makes it foolproof. We have connectors that you can hand tighten, get IP67, they're keyed, they're color coded, they're marked. So in terms of reducing the time on site, the labor, reducing the chance of a technical problem, working out in all kinds of weather. And, IoT, we're just seeing a lot of applications where there's needs for GPS, for LTE, for Wi-Fi, for Bluetooth, all in the same application. It just makes sense to bundle the coax together and to use a multi-port connector. Just an example of some of those, the small cables that we're currently working on. You see one there where it's even got an outer braid, extra layer of shielding over the plenum inner cables. And I think this is the last slide here. It's a coil cable, very similar to like an old CB cord type of thing or a phone cord. We've seen some applications where, on the blades of an earth mover, where there's, the customer doesn't want any sag in the cable when the blade is moving. We've also used these with tandem tractor trailers. So just one other thing that can be done, and just, again, sky's the limit, but we're always looking for, special applications, and that's what we do. We're coaxial cable. We're pretty narrowly focused in terms of RF interconnects, and pretty much, from A to Z when it comes to coaxial cable, we got a solution for that. Now, I don't know if we can stop sharing here.
Thank you so much, Kevin. And now we have a couple of minutes just to ask everyone if you have any question or comment about the products that Kevin just presented us. And let's check if we have any questions. So we invite you to use the question panel. This is a panel on the right side of your screen, and you can send us any message if you have a project coming up where Times Microwave can help you complete your project. Here, the engineers can help you with your project, or if you have any questions about the products that we just see in the presentation, please let us know. So at the moment, Kevin, we don't have any question, but we're going to be sending this webinar to your email right after the webinar, and also we're going to upload it to our YouTube channel. So please, if you have any other question right after the webinar, you're seeing Kevin's email on their screen, as well as you have the email for AppCom support@appcom.net, where you can send us any questions so we can help you with your future or upcoming projects. Kevin, we thank you so much for the presentation that you just showed us. And I don't know if you want to add anything else to this webinar.
I'm sorry.
Yeah, I think you could. Time to say goodbye. Yeah, I appreciate you guys being on the call. Kevin and I are always here for support, and John Carlo can support you as well. So if you have any special applications, just email John Carlo and he'll get it over to us, and we'll answer questions as quickly as possible.
Awesome. Thank you so much for your support, and we hope to see you in future webinars with Times Microwave. This was a really good webinar, and we hope that everyone who was part of the webinar enjoyed the information that Kevin presented to us this morning. So we thank you again for your time, and we hope to see you in future webinars of AppCom. Please keep checking our website, appcom.net, for future sessions. Kevin, team, Giancarlo, thank you so much. And we hope to see you pretty soon. Thank you.
Yeah. I don't know how I got control of your computer.